All right, so today we're going to go ahead and do the demo for the Lab 8 modeling and spatial analysis. I've gone ahead and pulled up the file downloaded from the site. You can see that you've got a bunch of shape files in here, repeats from earlier on, and then you've got a repeat of some of the slopes and water and those kinds of things, the things that we might want to use during the modeling part of this lab. So then you're going to go into Pro, go ahead and start a new project. You're going to call it whatever you want, but I would say Lab 8. Oh, make sure you send it off to the right spot. As usual, I'm going to send mine into my drive. And into Lab 8 modeling. Okay, once that gets up and going, we're just going to review a little bit on doing some of the selections. This kind of idea of select by different ways that we might not have done before. So I'm going to go ahead and add in just a few of the Indiana layers here. So again, you can either go to your catalog tab if it's up or elsewhere, go through folders. Oh, I must have created a new folder. I must have unchecked the thing that was creating a new folder. If you ever get in this situation, just do that thing where you add a folder connection. Go straight through to your drive. And I'm just gonna, I guess there's multiple ways I could do it. The easiest way is probably just to go map that connection straight to the GIS folder. Then it comes up over here and I can go in, get to it that way. Yeah, I just created a subfolder within there. So I'm just gonna pull in most of these other ones here. There's a few other things that we've done already that I just want to show you how to do again. First thing we can do is we can use like a graphic as a way to reselect things over and over again. They have some spatial information, but they're not actually stored anywhere in particular. So I'm going to go to do this by going to this one here. And if I go over into where I've got my selection things, I could do all sorts of things like select by a lasso, where I'm just sort of drawing a circle. And it will select all of the things that were within the circle that I just clicked it multiple times, so it went away. But so there you go. So you can see you can do some ways to kind of do quick selections. You've got other shapes in here. You can trace things. You can do polygons, all kinds of things that you might want to do instead of just that general kind of rectangle that it usually does. We've already done some select by locations, but just so you see those again, select by location here. And if I wanted to do, say, whatever comes up, I'm going to come back over on the drawing order here. I'm going to find all of the libraries that are within a distance of a college, and I want that distance to be 2,000 meters. Nope, I should have unchecked use selected record here. In fact, it's actually probably not a bad idea since I had that lasso selection before to just clear that. Now I can sort of see everything. You can see them sort of popping up in there. And what you might have noticed is that I can actually do multiple inputs here as well. So if I wanted to find all of the libraries and public schools that are within a certain distance, 2,000 meters of a college, I can do it that way too. Now, another thing I want you to know is that you can chain things together as well. So if I wanted to do a select by attributes first, clear again. So I could do a select by attributes. And if I'm going to say find all of the highways, so if you remember, the highways have a field in there that is code, I think, yeah, which is interstate, state, and something else. I don't remember what the U is. So if we wanted to do this, we could do is equal to, I'm just going to do major roads, or code is equal to, oops. So I'm changing that to or code is equal to U. So it's saying where the code is equal to I or the code is equal to U. Now, alternatively, I can also do in here, there's includes the values. And in this case, I could just check 2 of them. So there's multiple ways to do the same thing. So this is going to select my major roads. Now, having selected the major roads, I could do a select by location to find all of the, we'll do libraries that are within a distance of the roads, highways, geez, using the selected features. So now it's just going to find the ones that are within that distance. And you can begin to see those if I were to open up the attribute table here. You can see that there's 286 of them that are within 2 kilometers of a major road. Okay, so having done that, you can see how you can sort of chain these together to find something interesting. That is part of the assignment if you're doing this for class as well, that we would want to be able to do that. The other thing that we wanted to do that we talked about here was being able to do spatial joins, where we can sort of permanently add or at least append the information from one attribute layer to another based on spatial location. So in this case, why don't we find the places here? So if you open up the places, you'll see that it has the name of the place, but it doesn't have anything about like zip code or anything about like anything else that you might count. It's got county, but not much else. So we also have this layer in here that's the zip codes of Indiana. So if we wanted to do a spatial join off of this, in contrast to like a relate, we got to start with the one we want to append things onto. So if we want to append the number or the zip code onto the places, we're going to come in, right click on it, go to joins and relates, and add spatial join. Excuse me. Our join features are going to be zip codes. We're going to keep all, we want to do intersect. We can choose permanently here if we want to add it on to the file permanently. We cannot, we'll leave it as temporary if we want to there. So if we do that, it runs for a second. And for every one of those places, it's looking up the zip code that it falls inside of. And now if we open up the attribute table for places, you'll see that we've gotten pulled over the zip code for that one. So it's a good way to kind of link these two things together. Now, just another example of spatial joins, because like I said, the way you do the selections are pretty similar. So if we wanted to say, find out what is the closest library to every public school, we could do, starting with public schools, joins and relates, add spatial join. In this case, we're going to do libraries. We don't want intersect. We want closest. And then if we want a distance field name, we could call it like how far away it is. We'll call it dist. And then if you were doing searching or anything like that, you can do that. So in this case, it should run about the same amount of time. And when it gets all finished, we should have within the attribute table for our public schools, the distance to the closest library, and then the actual, all the information from that closest library. So lots of things in there. Good to go. All right, so the next tool we talked about doing was the zonal statistics. For this one, I'm actually going to go ahead and just start a new map document because this one's going to be focused a little bit more on just the Notre Dame stuff. Oh, came down there for some reason. Just drag it up to where you want it to be. And I'm going to add in that data down here. Just pull in all this stuff, all the Notre Dame stuff. So when that's getting going, we're going to again bring in this spatial analyst tool called zonal statistics by coming up to the analysis tab at the top. I'm just going to turn off parks here. I don't need it. I'm just going to turn off a few of those. Go to the analysis tab, tools. You can just search for zonal statistics. If you wanted to, it's in toolboxes, spatial analyst zonal down here. And the one we're looking for is zonal statistics. In this case, we're going to go through for every soil. We can use the soil code. We're going to do a value raster off of the DEM. We want to do the average elevation for each one. I'm going to call this, I'm going to leave it temporary, but I'm going to call it mean elev by soil. Wait, problem there. Hit run. See if that'll actually run. Yeah, it's yelling at me about the spaces in this thing. I'm not quite sure why, but if that happens, you can always just come in and actually open the thing because there is no space in the name of that one. So I'm not sure what it's talking about. Hit run. Oh, you see it's actually added in the new version, that circular statistics thing I was talking about, which is what happens if you have slopes and aspects and things. So that's pretty cool that it did that finally. So it's looking up for each one of the soil types what the mean elevation is for that whole area, and it's going to give us a new raster from it. If you remember from before, I talked about these not being particularly useful because it's just one value for the whole thing. And what I like a little bit more is to do it off of the zonal statistics as a table. I'm not quite sure why it's giving me a warning and why it hasn't finished here, but it's just still writing it. But while that's finishing up, we can just start filling in the stuff for the other one here. Zonal statistics as a table. It's exactly the same. We would do input zones, be soil descriptions. Our zone field is going to be the same. Our input value raster would be the DEM. Our output table would be whatever we wanted. We got our statistics type. All these other things are good to go. Just for some reason, seems to have shut down everything. We'll see. We'll let this run for a minute. There we go. So the zonal statistics finally finished. You can see what it's done is that for every soil type, it's just rasterized it, and the only value within there is the mean. If I come back over here, it's on the same thing again. Just doesn't like that name for some reason. Leave everything else as is, Go ahead and hit run. Oh, I didn't give the table a particularly good name, but you could work that out if you need to. Failed. Let me see why. So if the server runs into the input path contains spaces, it does not. It does, but it also doesn't. I'm gonna try just bringing in this one too. Don't know what's going on with this one. All right, well, I'll try running that again at some point. But the basic idea is that it's going to bring up a table for you with all of the things that you want on it. Precisely why it's not allowing me to actually bring this in, I don't know. Because there really should not be a particular spot, unless it's the My Drive problem. But that hasn't been causing a problem any other time, so new fun one. So I'm just going to try real quick. This is probably what y'all would want to do too. So dump this in some random folder on my C drive. There is guaranteed no space in there. You could use my documents or anything like that for this if you needed to. Yeah, something worse is wrong with it than just that, because that should not be happening since there's nothing actually there. So I'm going to pause the recording real quick and I'm going to try restarting. Yeah, as with almost all things with ArcGIS, restarting the program fixed it. It was just some weird thing that was happening. So if that happens to you, just go ahead and restart the software. Just save it and restart. So if you open up the table, what you can see is now for each soil class, we have all of the statistics on there. This could very easily be joined back onto the table, all those sorts of things that we talked about as being useful in class. All right, so another one we might want to be able to do are those Euclidean distances that we talked about as well. So you notice we have this water shapefile up here. It's polygons. It's basically just the water that was used to make the DEM. You can see it all floating around there. The way to do this first one is, again, if you go into Analysis Tools, it is in Spatial Analyst Tools and all those things, but you could also just search for Euclidean distance. So here, you do your input is the water. Your output, I would call it distance to water. You could save this permanently. We'll probably use it in the future, but it's really easy to redo. Water. If there were barriers or anything like that, you could do it. I like to do this as 30. If you wanted to do any of these other things, you could. But there is one thing left that you want to do, and that is go over someplace we haven't gone so far in this one called environments. And it's showing us up here that they're going to call this distance accumulation in the future. So in this case, we want to set a processing extent. Basically, what this is saying is we don't want to just do the area of the water. We want to do the area of the whole section that we're looking at. So what we would do is come in here, extend of a layer, one of these rasters. The DEM is probably a good one to get in the habit of doing because it's big enough. It's the full area. So then when you hit run, it'll happily go in the background. And it should give us a measure that is just the distance away from any pixel coded as water, from any area coded as water in the original image. So once this gets finished, we'll be able to see it. And then we can move on to that cost-weighted distance that we talked about before. For this one, we're just going to use the slope as the only cost that we're dealing with. And what you would do in this situation is, again, go back into Analysis Tools. Whenever it finishes. Sometimes the view details will give you some indication of what's going on. I don't know why it thinks that I mined about 2 megabytes of temporary storage, but it does. This is just where you find all the information about what you've run and that kind of stuff. If you ever need to cancel something, you can do it there too. But you can also do it down in the corner here. Okay, so there we go. So now you see that it's done it all the way out to the extent of the DEM, whereas previously, if you'd only had 1 or 2 points, it might not have done it the full extent. So this is a pretty useful way to do it. Every pixel value is just the distance away from the nearest thing that is water. If we were going to do that as a cost-weighted distance, we would just go back to our geoprocessing. Again, that's just tools up here. The mouse keeps catching weird. We would do cost. So cost distance is this one. If we were going to do again, water, we'll do our cost raster is just the slope. Again, you could do something more complicated. Cost dist to water. In this case, it will probably go all the way out because it's using the cost raster in there as well, but it's a good habit to get into to come up and go ahead and set the processing extent as well to just be something like the DEM. Now when we run our cost distance, you'll see you end up with something that looks similar, but not exactly the same. Okay, so this came up and you'll see it looks like this. There's one small thing that I forgot about when I was telling everyone to use the slope on this. And this is something you're going to want to run into as well. So you see what's happened is that the slope is gone, so there's no cost distance in a lot of places here. That's because the slope there is 0 because it was built from a tin. Those are perfectly flat areas. And when the slope is 0, the cost is 0 and it multiplies it by 0 and it goes, or divides by 0 and it gives it an error. So you lose those areas. So there's one more step we just have to do before we can get this one totally ready. And I apologize for missing that for a second. So the first thing we're going to do is go back into tools and you're going to search for raster calculator. And really all we're going to do, I'm going to remove this cost distance to water. We don't need it anymore. It's broken. We're going to come down to Notre Dame slope. And we're going to just double click on it so it comes up there. And you press plus 0.001. It just makes it not 0. We're going to call this fixed slope. Go ahead and hit run. So it shouldn't look any different when it finishes up. But what we're going to have is a layer that has that slopes are no longer 0. They're 0.001. and everything else has been raised by just a little tiny bit as well. That just removes that possibility of having the divide by zero error and like losing those parts. Okay, you can see that this fixed slope is really functionally no different looking. It's just had a little bit added to it. So I'm going to just go back, go to my history actually here, and if I find that cost distance, if I double click on it in the history, I can actually get the same thing again. I'm going to change my cost raster over to fixed slope and hit run. Okay, with that fixed thing, you can now see sort of what the cost distance looks like and sort of how that compares to a Euclidean distance, where it's actually this sort of synthetic layer that's including both things within it. So it gives you a better sort of indication of kind of how hard it is to travel from one spot to another. So walking all the way from up here down to there is pretty easy because there's not a big slope in the way. Getting across the river is not the easiest thing. We didn't actually code water as anything different, or it might have been a little different. But all in all, it gives you a good idea of sort of how hard it is to get away from water throughout the whole of the landscape here. So up next, we're going to work on kind of pulling all this together into a model. So far we've been sort of using these individual rasters and things to represent individual layers. But really what we want to be working on now is combining them into a model. And rather than do something particularly serious here, we're going to go ahead and combine 3 different layers together into this sort of ideal location for a hobo habitat. And we're going to do this at the state level just because of the data we're going to work with are a little bit more clear on this level. So we're going to take 3 different factors and we're going to reclassify them so that they're similar. We're going to rasterize them. And those 3 factors are going to be 3 things that were sort of considered to be important for a hobo population. The first of which is they want to be away from areas of high population. We have that in the census tracts here. They want to be near railroads. We have that here. And they want to be near libraries. We have that here. There's reasons for all of this given in the demo notes if you want to follow along with the really silly thing that I did. So the very first thing we want to do is convert the census data here. So if you open up the attribute table, you'll see that you have census data that has population and area and things like that in it. So we're going to go ahead and do that first by just flat out converting this data into a raster. So right now it's vector data, but we want to turn it into raster. So we're going to go into our tools and we're going to choose feature to raster. So this will do anything, but in this case, we're going to go ahead and do census tracts. We do our field listing. We're going to do population. Technically, we should calculate a population density and do that, but I'm not going to worry about it. We're going to call this, we leave it in the database. We're going to call it hobo population, or hobo pop. And I'm just going to turn this into 1 kilometer just to make it a nice round number. Go ahead and hit run. Okay, so as we can see, that reclassified the whole population, or sorry, the whole state off of every census tract and its population sort of weighted just off of the number here. So a couple things that could have been done a little differently. When I'm looking back at this now, what I'm seeing is that could have probably set the cell size to be a little bit smaller. That does not look particularly good there. So I'm going to go ahead and just rerun this real quick. Census tracts, population. And why don't we go ahead and stick that as, I don't know, we'll do 500. I think I did 1,000 last time. Why don't we do 50 just to see what happens? All right, so when that gets done, I bet we'll see something that looks a little bit cleaner on it. That's just to keep it from being really, really rasterized. So once we've finished with this, the next thing we want to do is reclassify this so that we have areas that are of high population are low ranked, and areas that are low population are high ranked, because that's sort of how it contributes to our model here. There we go. That looks a little bit more like what you'd expect to see. So what I'm going to go ahead and do is come back into my geoprocessing tools, and I'm going to look for reclassify. I'm going to bring over Hobopop. The reclass field is just value. Down here, it's put it into 9 classes. I'm going to hit this classify button. I'm going to do, we'll do natural breaks. I'm going to switch it to 10. And what I want is I'm going to hit OK. So now I see 0 to 390, 379 is actually a 1. What I want to do is reverse that so that the low populations are 10s, high populations are lower values. And I'm going to call this Hobopop reclass. Doesn't really matter if I check that or not, but I'm going to go ahead and do it. Okay, so the next thing we're going to do is another layer where we're going to try to get to the distance away from libraries. So you see it's ranked it just like that. So the next one we're going to do is we're going to go back into our geoprocessing tools. We're going to do a Euclidean distance. And we're going to go away from libraries. Call this Hobo libraries. So this is just another way of getting what was previously vector data, these libraries, in as raster data. We're going to do nothing like that. Minimum distance, I'm going to go back down to 50 again. Distance, meta, planar, direction, I don't need any of this. I do want to go ahead and put my environments as, in this case, what I actually could do is if I wanted to come over here and do the extent of the layer, and I'm just going to do the census tracts. There is a way in here as well that I could mask this. This might actually be a good idea. It's not in the demo notes to do this, but if I did masked it off of the census tracts, then I think what that'll do is it'll actually keep it from going all the way outside of the state also. So it should run for a second. Maybe a second longer than I thought it would. And when that's finished, what we're going to do is just go ahead and reclassify it as well. Because when we reclassify it, what we want to be able to do is have it, again, ranked so that the things that are close to libraries, low distances, are 10s. The things that are far away are high distances. There we go. So what you see is it's clipped it off at the thing, and anytime it's nearby, it's getting a low value. Anything that's further away is getting a higher value. This is, again, something we're going to go through and reclassify. Our input is going to be hobolib. We're going to do 10 classes. Okay, I'm going to go ahead and do this as hobo lib reclass. And again, I want to make sure my low stuff is highly ranked, so I'm going to reverse new values. That's not every time, but in this case it is. And there we go again. So our very last one we're going to do is off of the railroads. In this case, we want to make sure that we're near a railroad. Hobos have to be near railroads. So again, we're going to do Euclidean. So we're going to do railroads. Output distance raster, we're going to call it hobo rails. Also make this 50. I'm also going to come over here and do a processing extent as the same as census tracts. And I'm going to do a mask as, I'll just the same as zip codes. Maybe it'll be faster, it's less of them in there. Okay, so I'm going to go ahead and run that. So when that's finished, what we're going to do is reclassify, but I'm going to reclassify it in a little bit different of a way. What I actually want to do here is I want to make this so that if you are to be a hobo, you have to be within 5 kilometers of a railroad. Otherwise, you're not. That's not possible. It's not a niche that they live in. So what we're going to do is reclassify this one as a binary, so we can see sort of how that tool works. So when we do this, what we'll end up with is anything that's less than 5 kilometers will be a 1. Anything that's further away than 5 kilometers will be a 0. And that's why, so if we multiply it at the end, what we end up with is a case where we can't have these further away distances. They just get removed even if they're highly ranked. So I'm going to go back to my reclassify up here. Yeah, click on the wrong thing. Bring in hobo rails. Our output is going to be hobo rails reclass. Our value is going to be there. I'm going to go into classify. I'm going to switch this over to 2 values and hit OK. Now, what you might notice or not notice is I can come over here and actually change these things around. So between 0 and 3,000, I could have done this in the other part too. Is that in between 3,000? Did I say 3 or 5? I said 5, didn't I? So 5,000. These are in meters, so this is why it's 5,000 meters is 5 kilometers. I'm going to change this to be, I'm going to leave this as 1. But then over that, I want to change this to be no data. So I'm going to do this by just typing in the word no data, just like it is written down below there. Is that not letting me do that? Yep, there we go. Now it's working. I could also remove that class and say change missing values to no data, but this works just as well. So 0 to 5,000 gets a 1, 5,000 to 6,000 gets a no data. Well, actually, I'm sorry. I put that as a 0. Hit run. This is I was thinking ahead to something else we do. So don't do that. Make sure that it's 1 and 0. Don't listen to me there briefly. Otherwise, it would remove it from the model entirely. That's not what we want to do at this point. There's a situation where we'll do that in the next week's one, and I've just gotten ahead of myself there. Okay, so now we have it as 0 and 1. Anything that's close by will get a 1. Anything that's further away will get a 0. And we're going to go back and create our final model using the raster calculator. What we're going to do in this case is, because that hobo Rails reclass is binary, we're going to take that, we're going to multiply it by the average of the other two. So lib reclass plus population reclass divided by 2. So you should look up something like that. And then right at the end here, we're going to call this thing hobosity. Oops. So Rails reclass is binary, multiplying it by the average of the other two, which is this one plus that one. If you had 3, it would be divided by 3. If you had 4, it would be divided by 4. So this will finish up and we'll have a model of sort of the ideal habitats for hobos around the state of Indiana. Obviously, this is a silly, fanciful example, but you can sort of see how you would do this kind of thing if you were building one of these things for real. And sure enough, we have this measure now. You can change your color ramp a little bit. Oops. If we wanted to change the color scheme to be something that was a little bit more bright, you can see that. So anything that's a 0 here means that it's too far away. And then you can sort of see these higher areas are the places where it's both a low population and also near a public library. There's a few of them down in here as well. So you end up with a situation where you get a good model for kind of where you would look for this particular type of species. All right. So silly example, but the kind of thing that you would do if you were building one of these things for real.